Today we're going to dive into the comma OK pattern in Go. It's definitely one of the most useful idioms you will encounter. The pattern works with maps, type assertions, and channels, and it helps you write safer, more explicit code. So what is the comma OK pattern? The comma OK pattern is Go's way of giving you two pieces of information at once. Firstly, the value you're trying to get, and secondly, a boolean indicating whether the operation was successful or not. You'll see this pattern in three main places: map lookups, type assertions, and channel operations. Let's start with maps and see why we need this pattern. I've got a simple function here, main, where I create a map literal with one value for Alice and a score of 0. I then get two variables. I get Bob's score from the scores map. I then get Alice's score as well. We then print out both of those scores. If we run this code, we'll see that we get Bob 0 and Alice 0. And the problem here is the ambiguity. When you access a non-existent key in a map, like we've done with Bob here, Go returns the 0 value for that type. And we can see that here, Bob gets 0. But what if 0 is a valid value in our map, like it is for Alice? We can't distinguish between the key doesn't exist and the key exists with the 0 value. And this creates bugs in our applications where 0 has a meaningful value and you've explicitly set the value to be 0. So let's see exactly how we solve this problem. What we can do is we can go ahead and create an if statement around our Bob score here. So we'll do if Bob score, comma exists. This is the comma OK pattern coming into play here. And then we'll check to see whether exists is true or false. We'll then go ahead and print out Bob's score. And you'll often see it's called either exists or OK. And we'll use OK for this one. Otherwise, we will just print out that Bob's score does not exist. So let's print out Bob not found. We can also do the same for Alice. So we'll do if Alice score, OK, score, and then OK. And we'll print out Alice's score here. If we go ahead and run this, we will see that we get the correct output as you would expect here. Bob not found because we've not explicitly set that value. And then we get Alice at 0 because we have explicitly set that value. And that's a really useful thing for the comma OK pattern to know whether a value has been explicitly set within a map. Now, type assertions can panic if you guess the wrong type. I've got a simple bit of code here, which has got an interface of a string. We're then going to check the type is an integer, and we'll run that code. And we'll see here that we get a panic. And we get a panic because the interface is a string, not an integer. So when you perform a type assertion and you get it wrong, your program will crash and panic. And this is especially dangerous when you're dealing with external data sources like perhaps a JSON API or user input where you're not 100% certain of the types. And again, the comma OK pattern can save you here. We'll go ahead and update this code to use the comma OK pattern now. So if number, comma OK, and we've got our comma OK pattern, we'll then check whether OK is true or not. If it is true, we'll just print out the number. Otherwise, we will print out that, let's print out data is not an int. We'll save this, let's clear the terminal, we'll run this, and we see that data is not an int. And we can go ahead and delete this here, set it to be an integer, and we will see that we get the number printed out as we would expect. And so here, the comma OK pattern approach eliminates the panic risk and gives you control over how to handle type mismatches. Final use case of the comma OK pattern is going to be in channels. We're going to use comma OK to detect whether a channel is closed or not. Let's start off with the problem. So we can see here that we're creating a channel of integers with two values. We're then passing in two values, 0 and 1. We are then explicitly closing the channel. We're then grabbing those values, so we should be 0 and 1. We should get value 0, value 1, and then we also grab a third value from our channel, but our channel is actually closed now, and we print out all three values. Let's see what we get. we get 0, 1, 0. And this happens because when you read from a closed channel in Go, you get a 0 back. If your channel normally carries 0 values, you can't tell if you've received a real 0 or if the channel itself is actually closed. And this can lead to kind of infinite loops or obviously incorrect program behavior and bugs, etc. So how do we solve this using the comma OK pattern? Let's go ahead and use a for loop here to read from our channel. So if now the comma OK pattern, we'll do if value OK, and then we'll read from our channel and we'll check to see if OK is true or false. We'll then just print out the value. So we'll do value. Otherwise, we will print out that the channel itself is closed. So channel closed, and we'll just break out of the loop. If we run this, we should see 0, 1, and then channel closed. And that's exactly what we see. And ultimately, the OK boolean here tells us whether the channel is open or not. When OK is false, we know the channel is closed and we should stop reading from it. So when should we use the comma OK pattern? Well, with maps, we need to distinguish between missing keys and 0 values, especially for things like lookup tables or caches. It's a really useful pattern. For type assertions, always use comma OK unless you're absolutely certain of the type. It's better to be safe than sorry, especially with panics. With channels, use comma OK when you need to detect channel closure, particularly in things like worker patterns or when processing streams of data. To sum up, the comma OK pattern is Go's way of making potentially unsafe operations nice and explicit and safe. When you're working with maps, type assertions, or channels, this pattern really helps you write more robust code by giving you the information you need to handle those edge cases properly. It's a simple pattern that prevents a lot of runtime surprises.